All right, so I think we can start, and I will begin by sharing my screen. Second. Okay, so share screen button. All right. So today we're going to start talking about control structures. I don't believe that last week's session was clear because during the week, nobody reached out to me to say they had any problems with the content of last week's session. So I don't believe the session was clear, but if there is any challenge, any problem, or you can always reach me, or you could always unmute yourself and ask. Like I always say, this is a live class, and that's one of the perks of having a live class. If you don't understand anything that is going on, you have the luxury to just call and ask your question. All right. So we have talked about data types, talked about strings, we talked about text, Boolean, integers, floats, and all of that. So today we just want to advance the discussion a bit. And that's why we'll be talking about control structures. And in programming, practically every programming language, there are just three control structures. The first is procedural. The second is decision. The third is loop. These are the three building blocks of every programming you would ever need to do. You first need to determine the flow of the program you're writing. So what steps should come before what step? For example, if you want to cook right now, boiling water obviously should come before putting the rice inside the pot, right? Because if you change the order, you put the rice inside the pot first, the rice is going to get burnt. So there is an order in which things should flow. And that's one of the first things you must do as a programmer. And that order will be reflected in the way you write your code, because the first thing that needs to be done has to come first in the line of code, before the second, before the third, before the fourth. So that's how the procedural control structure works. And one of the things it forces you as a programmer to do is to sit down and think through what you want to achieve, because it's until you determine what you want to achieve, then you determine the steps that you need to take to get to where you want to get to. So that's how it works for a programmer. You sit down, think big picture, try to find out what it is you want to do. And when you find out what it is you want to do, the next thing is your roadmap. How do I get there? So when you have decided how you're going to get there, what you would land at is something called pseudo code. Now, most people don't do this because, I mean, it's most times, especially for data scientists, what we're trying to achieve can be done in maybe 10 lines of code or in 15. So we really do not see the need to sit down and plan elaborately. But if you were doing real proper programming, or you're trying to build something complex, you will be forced to sit down and write pseudocode. And another thing that, Python programmers, not Python programmers, data scientists that use Python do not do is flowcharting. We really do not believe in all of this. Why? Because what happens is that as a data scientist, most times you use Python like, use it like a calculator basically. So you just use it as a means to an end. Just, okay, Excel cannot run this computation for me, let me just quickly run it in Python. And that's the way many times the data scientist uses Python. We really do not use Python as if we're trying to build something, because that's not what the data scientist is trying to do really. Data scientist is trying to explore data. It's not trying to build anything, all right? So, but the software engineer is trying to build something. So he will have to sit down. There's nobody that builds a house without having to sit down and even come up with a prototype or come up with a model or something, no matter how small or how untidy it is, to be able to know, okay, what is this thing I'm trying to do? What are the steps I will need to follow? What are the teams I'll need to assemble? What are the things that I need to get done, to be able to achieve this thing I'm trying to achieve? And when you are not thinking like that, obviously you're a data scientist. You're just trying to achieve just something very quick, and that's it, just like a means to an end. So that's why R and Python come across as very, very beautiful for data scientists, because number one, it's very short as in the cycle, the development cycle, it's very short. So what I just want to do, run a machine learning model, 6 lines of code that fits or predicts, and I'm out of here. But it's not like that for the software developer. So what I'm trying to do is to put you in that software development paradigm, because really, and that's one of the reasons why many data scientists struggle with Python, because Python is a programming language. So since it's a programming language, there is the assumption that you have understood the rudiments. And the rudiments of Python obeys everything, all the programming paradigms. There are different programming paradigms. There's DRY, don't repeat yourself. There's object-oriented programming. There's, there are different paradigms, all right, depending on how you want to classify them. So Python obeys every one of them. And if you do not understand each of these paradigms, it's going to be a problem for you when you start seeing something. For example, when we say maybe, when we write for example, if I write something like this, maybe text dot splits, all right? Why do I even have to put the bracket at the end? Why do I, have to use the dot? Why do I not do this? Just, split and then have the text, why, there are a lot of whys. And most times, if you're from a data science background, you would have just been taught, okay, so when you want to split a text, just press text dot split. And the reason is simple, because the data scientist is just moving from just looking for a means to an end. But that's not really like the best way to learn Python. And that's one of the quarrels that I have with many of these, training schools or boot camps, because the moment they just call it a data science training school, that same mindset of, hey, I want to achieve an end just comes in. So you see people cramming a lot of syntax and all of that. But sorry, one of the things that I've discovered is that if you do not understand programming paradigms, especially object-oriented programming, you're going to struggle as a data scientist to cram syntax. And that's one of the things that I don't do right now. I don't cram syntax. Why? The reason is simple, because I understand what I should look for. So I know, okay, so this is a method inside of this class. And this is an object in this class. So how do I reach this object? And what are the methods that are particular to this class? And so by the time I just look at it and I just see the picture, okay, I understand. And anytime I get stuck, it's just a question of, finding out what are the methods in the class. For example, let me show you just a little trick. Now, let's say I have a list. So let me call this list. Sorry, don't mind that spelling. List A. All right. Now, if I have list A, just give me a second. Just a second. Okay, so list A is let me see. Let me just say Ada and Michael. All right, let me just have 2 names in that list. All right. So now, if you look at this list A, if I just look at this list, let me just say type list A. This is TYPE. Pardon my typo. All right, so you would see that the system recognizes that's a list. Now, anything that is a list has unique methods and classes that are available to it. So if I want to maybe do something to this list right now, I don't need to cram the syntax. Even if I've forgotten the syntax, all I just need to do is to come and just run, let me just put this here. All I need to do is to run something like this and just say dir, and I put list A. And it will bring out all the methods and objects. Sorry, to bring out all the methods and the properties of that class for me. All right. You can see there is the append method, there is the clear method, there is the copy method, there is the count, there is the extend, there is the, all these methods. So I can say, oh yeah, the one I need is pop. All right. Why? The reason is simple, because I know that this list is an object, is a Python object, and being a Python object, I can call on the dir, that's the directory function of this object, and it will bring out all the properties, which are all of this, and all the methods, which are all of this. Now, when we get to object-oriented programming, properties and methods become very, very clear. All right. So that's why when you sit down to understand the rudiments of the language, then you won't have any problems with, okay, what is that syntax again? If I forget anything, I'm working on the list, all I just need to do is just to call on the directory and check on the, oh yeah, then I get that. Yep. All right. So that's how these things work. So let's go a bit more on our control structures. Like I said, my desire is so that we don't just end up as data scientists in Python. We end up as builders, as software people, So tomorrow, if they ask you to build something very interesting, you would not say, I'm a data scientist. The only thing I know how to use is pandas. Or they know, like I told you, I build automation, anything that I need right now to do my work that is like repetitive. I just build something, an app to just take care of that. So that's the paradigm that I think you should use. Does there work on any IDLE? Absolutely. You could try it anywhere. You could try it on even this online one that is, for those of you who like to work when you're, on the move and probably not have your laptop, but you want to still just play around with code. You can use this W3's playground. It's amazing. All right. So you can decide to, let me just create this list A. Let me just copy this code so that I don't have to type too much. So paste that here. And all right, so list A, and then I would say, give me the directory of list A. And when I run this, watch what it gives me. So come on, don't take so much time. Okay. Let me try running again. Basically, what I'm just trying to show is that it can work in any place. I don't know, maybe this is my internet connection just misbehaving, but it should bring out, it should bring out, okay, you know what, maybe I should run it in, let me launch my Visual Studio. Just a second. Visual Studio. Okay, so I'll share my screen completely. Right. Okay, so I'm just starting up my Visual Studio. Close this. Do you want to save? No, I don't want to save. So just close. All right. So let me open a new. Let me just open a new document. All right, new file. And so I'm going to select Python. Okay. All right. So now let me run that same stuff that I had here. Oh, I closed it. Okay, so let me pick this one again. Just A. And I will run dir lists A. All right, so once I come here and I run Python file, okay, save as class. Let me just call this list A so that I can delete it much later. All right. So this is my list A.py, and then I'm going to run it right now. So just look at this place. Sorry. Let me see. Why is it giving me this error? Just a second. Okay. Yep. Base Python 388. Okay, so let me check this and make sure it's not a setting with my Jupyter notebook and my Visual Studio. All right, so list A is not defined. So why would it say list A is not defined? Because, okay, let me see where the problem is. Just a second. Invalid syntax. Okay. Okay, let me create a list. Now, let me say lists B is equal to, and let me call this Mike and Ben. All right. And let me say print list B. Shouldn't be a problem. Okay. Okay. So this was going to happen. Let's see. Okay, so let me check. This shouldn't be a problem. Okay, so let me run this. I think I know the problem. Why it's giving me this error. I think the error is because Where is that conda activate? Yep, this is it. It's not just connecting with this. Yep, Naconda 3. I think I know that's, yep, I think that's why, I think that's the problem. The problem is I will need to see, okay, so Python activated. Let me see, conda base. Okay. I think I know why it's doing that, because I have yep, this is my base conda. Oh, okay. Let me see why it's recommending this. I think maybe because that's the virtual environment I'm using in my Jupyter notebook. No, it's not. Let me use this base conda. I don't know why it's that slow, but I'll check it and I'll fix it. But normally it should. It wasn't giving me this error. But I don't use IDLE, but let me just see, because why I don't use the Python IDLE is because I use Anaconda installation. So it comes with its own, let me see. Sorry, I just need to get this fixed right now. Okay, this is base conda, and I'm running my Jupyter notebook from which kernel right now? Let's see, it should be my base conda. Let me see. Yep, I'm running it from base, yeah. So it shouldn't give me a problem. Okay. So while I wait for Spider to come up, I will just continue with this, but I don't know what's wrong with that Visual Studio. I'm sure I'll get it fixed. Okay, so let's talk about flowcharts basically. Now, how do flowcharts work? Flowcharts are just a way of you processing your thoughts so that you can create the procedures and the various lines of code that you require to run them. Okay, so I think this one is up now. Okay, cool. So here, then is equal to A. Okay. So I think this one is still booting up. Still booting because it has not fully recognized the variables. So if you can see, when it fully recognizes them, when I hover around it, okay. So let me see, prints. Okay, yeah, I think it's now good to go. Let me run this now. So yeah, so it can print list A now. What if I run dir, that's the directory for list A? Let's see. It doesn't come out. Okay, Tima, you're up to something. You're up to something. I just know when I run dir, in Jupyter, which is where I do most of my work, you know, it just comes out. So this is surprising. Oh, I think I know why. Come on. Oh no, this is my Jupyter notebook bad habits. Oh, yikes. This is why. That's it. I just forgot totally that when you're doing anything with any stuff that is not Jupyter notebook and you want it to come out on the console, you have to put the print keyword. Oh, my bad. Sorry. Sorry. So yeah.
Yeah, at least.
I totally forgot. It's one of my Jupyter notebook bad habits. And that's the thing with Jupyter notebooks. Jupyter notebooks makes you a lazy programmer because there are a lot of bad habits that it has that other IDEs do not have. So that's the, man. I was wondering, how can that thing not work in Visual Studio? And I've not heard it before that I cannot access directory in any IDE. So yeah, bad habits. Right, so I can close this. I can close this. Yes, it might work in your Visual Studio, your VS Code, if you are, let me say, if you are using what do you call it now, notebooks inside your studio, so it might just work. Okay, so let me open a PowerPoint document. Should I use a PowerPoint now or whiteboard? Let me use PowerPoint. I think that one is faster. All right, so oh yeah, print will work. Anytime you want something to come out on the console in Visual Studio or any other IDE you're using, you have to wrap it inside a print statement. If not, nothing will happen. So I just remember that right now, man. My bad. Okay, so let's talk about flowcharts basically and how they work. Now, you might be faced with a task, all right? And the task is to arrive at something, maybe a program, a maybe a program, something, anything, right? You know, it's usually like anything you want to do at all, apart from data science work, because most times the data science work is already, pre-planned. So I know when I want to bring in my Excel sheets, I have to do PD dots data frame, or PD dots data frame or read CSV or whatever data frame, whatever method it is you want to use. It's already defined for you. So, you're not you're not wasting your time doing all the flowcharting. But let's just say you want to build something, all right? And there's this game I saw online, and it's a very funny game. Okay, so this is it. It's called the shoe size riddle. So this is it. Take your shoe size to the nearest integer, all right? Multiply it by 5, add 50, multiply it by 20. If your birthday has happened this year, add 1020. If it hasn't happened this year, add 1019. Subtract the year you were born. The answer is your shoe size and your age. The first part, which is the 10, will be your shoe size. And then the second part is your age, all right? And it works. Okay, so I'm not going to ask you to voice out right now, but we could try it if you want to, right? But let's assume that right now you want to package this thing into an application that anybody that just bored can just play. And first you want to ask yourself, how do these three things come into play? We talked about three things. Um, we talked about the three control structures: procedural, decision-making, and looping. So let me just show you how it comes into play. But before I talk about them, let me just talk about flowcharts basically. Now, what are flowcharts? Flowcharts are just a visual representation of all the steps you're going to take to arrive at your destination, I told you about two things, pseudocode, flowchart. Pseudocode are just like steps. For example, so if I want to write the pseudocode for this program, what I'm just going to do is I'm just going to, come to my application that I'm working with, and then the first step would be, what's the first step in the Riddle again? Your shoe size. Okay, so when I'm doing pseudocode, what I'm going to do is the first step would be step 1. Second. Okay. Okay, so step 1 would be say get shoe size. So just in case you don't know your shoe size, and you have to go and consult your shoe for it, fine. So that'll be the first step. The second step would now be to multiply that by 5. All right, so would have to say multiply shoe size. And when you're doing pseudocode, you really want to be explicit, because there are a lot of things that will, become clear as you write the pseudocode. So you have multiply shoe size by 5, all right? And the next step would be to add 50 to this result you just got, right? So one of the things you do in Python is that, because Python is well, not just Python, because the computer is very dumb, everything you do, you have to give it a name and use it as a variable so that it has a place in Python's memory. If you just tell Python multiply shoe size by 5, okay, it will say, okay, when I multiply by 5, what's this new figure that I have now? What is this new figure? What should I call it? You see, that's why we give things names. Like, for example, you can call this now results, or you can call it anything you like, all right? So, but if you don't call it anything, Python will really not have it in its memory, all right? And you might end up having a very abstract kind of code. You might even end up not being able to write the code. For example, let's assume I do not name this thing result. So let me just hide this now, all right? So now the next step in the project says that we should multiply by 20. So now what are we multiplying by 20? Is it shoe size? Because you have to be explicit to the computer. You have to tell the computer step by step what is it going to. So right now, if you tell this computer, okay, computer multiply by 20, it's going to ask you, what am I multiplying by 20? You're not going to say, okay, that thing I got by multiplying shoe size by 5. Computer will now say, okay, what is the name of that thing you got by multiplying the shoe size by 5? Now, do you get the logic why we name results, we name solution to steps, as variable names? I hope you get it. That's why we do that, so that at every step, the computer knows, okay, when I multiply shoe size by 5, I get results. Now, that result I get, I have to now multiply it by 20, right? So you multiply the result by 20. Now, you go back to your code again, not your code, your instructions, all right? And then the next step says, if your birthday has happened this year, add 1020, but if it hasn't happened, add 1019. So you come here and then you implement that again. So step 4 will now be, if your birthday has happened, add 1020. So if birthday, all right, that's the way they put it in programming language. Some people say if birthday is true, but this is bad. This is bad practice. So don't do this. Just say if birthday. All right. So if birthday, that means it has happened this year. Add 1020. All right. Now the computer is going to ask you again. Add 1020 to what? Add 1020 to the results that you got by multiplying results by 20. And it's not going to ask you, okay, so what's the name of that thing that I got by multiplying results by 20? I don't know. Computer is just going to tell error. right? So it means you also have to name this variable. Now, there are two ways you can do this. You can decide to call this results1 or result new, but that will mean a duplication of variables, because what that means is that this result will be useless after you calculate it, since it's now just helping to do this. But you can actually just call it results instead of result1, so that the computer will now know that, okay, so now I want that whatever you get by multiplying this will now be the new value of results. So you will now cancel this one from its memory and put this as the new value of results. So that at the end of your equation, you do not have too many variables hanging around. Now, Python is a very merciful language when it comes to garbage collection, because what you have now is, if you created this as result1, this step now you created this variable as result2, all right, and like that, you have a lot of garbage variables, all right, just hanging. And there's some languages that are not very efficient with garbage collection. Garbage is a variable that you really are not referring to, when you are at runtime. So in order to not overload your program with garbage, especially when you're done running, you just need to use stuff like this to when you're creating a program. All right, so that's how it works. Now, what I'm going to do now is, I've just shown you how each of this works. Let me now run the flowchart so that you can see how a flowchart helps in building applications. All right, so let's run a flowchart. Now I'm going to create the flowcharts. Just change this. Okay, the thickness is fine. All right, so remember, for flowcharts, whenever you want to start a flowchart, the first thing you want to have in the flowchart is the beginning of that's what you want to first show, the beginning. All right, start. So usually start is displayed by a circle. All right, so if you look at all of this, you'd see, or when we start playing around with these shapes, you get to know what they do. So the start of the process usually is a circle. All right, so this is our start. Now, the next thing is, we want to look at this also. Okay, the first thing we want to do is to get shoe size. All right, so that's the first thing we're going to do. And it can be, you can call that input. And what is input? Input is shown by this, is it called a trapezium or a parallelogram? I think it's a parallelogram. Yeah, if I remember my geometry very well. All right, so I think it's a parallelogram. Yeah, parallelogram. All right, so that's input. So what are you inputting? That's the first question. Here, this input would be called shoe size. All right. So the next thing that you now want to do, according to this riddle here, is to multiply shoe size by 5. So you come to this place and you do a down arrow, and it's another. Okay, no, this is a process actually. So this is supposed to be square, not a parallelogram. So multiply shoe size by 5. Then the next thing that you have here is add 50 and multiply by 20. So we have another process here that says add 50, all right? Then we'll have another process here that says multiply by, let me just get that, multiply by 20, okay? So, all right. So multiply by 20. Then we are going to have a connector here, which is just a circle, all right? Then another connector here, just a circle, all right, to show this. Some people would say put an arrow, just to show the connection, or a connector is used when you run out of space like this, just to show continuity. All right, so the next thing after we do this would be, see, okay, if your birthday has happened, add 1020. Now, this is where the rubber meets the road. You now have to ask yourself, has your birthday happened this year? That means you have to take a decision. And this is where the decision structure comes into place, because if you remember, all the while we have been doing just procedural, the steps that to follow. So now we have to make a decision. And a decision is shown by this. I think this shape is called a rhombus, if I'm not mistaken. All right. So at this point, we have to ask ourselves the question, did you or have you had your birthday yet? Let me just use your birthday yet. So if yes, what should you do? If no, what should you do? So usually this place would be for no, and this place would be for yes. So this place for no, this place for yes. Or let me just use, okay, some people call it that, but okay, thank you. Okay. All right. So if your birthday has happened this month, then add, if your birthday has happened this year, add 1020. If not, add 1019. So if your birthday has happened this year, then what you should do is add 1020. If your birthday has not happened this year, then add 1019. Okay, so after this, what happens? Then subtract the year you were born. So the answer is your shoe size and your age. So finally, we come to the end. Subtract the year you were born from the value you get here. So we have another process here. All right, subtract your year of birth. And when you do that, you will have the year you were born. All right. So with that, we get to the end of the program. Now, here, if you have not, if you did not have your birthday, you add 1029 and you will still land here. Because whether you have your birthday or not, you will still land here. And, one of the things you would notice is that at every point in time when you make a decision, where the two decisions move, there must always be a convergence point. Now, there is no decision that just goes and just forms another ending per se on its own. It might happen, but it's very rare. I've not really seen, right? But I've learned not to say anything is impossible, especially with science. So it might just be possible, but yeah. So that's the flowchart. So now if you want to implement this in Python, it becomes very easy. If I give any programmer this to just look at, oh, he already knows what I'm trying to do. So now we're going to implement this in Python. How are we going to do that? I'm going to use my Jupyter notebooks. So the first is, sorry, that's my Jupyter. Okay, so let's do that here, the shoe size logic. So just add one cell here. Okay, So the starting point is we get shoe size. So we have to create a variable called get shoe size, all right? Or you can call it shoe size if you like. Shoe size, all right? And that variable has to come from the user. Yeah, please go ahead. Tima, go ahead, ask your question.
No, I'm not asking any question. I'm only contributing.
Okay, all right. So how do you get user inputs? In Python, you use the word inputs. So amazing. So in some other languages, you have to, like Java, you have to import something called scanner. So sometimes you just ask yourself, is scanner? It's not something we used to scan a document, It's just funny. All right, so this is it. Your shoe size is going to be inputs. Now, this is how this keyword works. When you say inputs, it's expecting something from you. And what it's expecting from you is just a string that will explain what this person should input. So I'm just going to say enter shoe size here. Now, when I do this, let me just run it. You'll see it brings out an input box. That's basically what this input does. But this is where you have to be very careful when you're using the input to receive anything. Remember that this, whatever value we are using here, should be a figure. Now, if I put maybe Tima here, the system will accept it. But if what I'm trying to do is a mathematical operation and I have Tima here, which is a string, I'm going to get an error when I'm implementing my code. So what I would try to do is to now tell Python, hey, whatever the person imputes here, convert it to an integer. So that's why we normally have to put this int here to say Python, convert whatever the person puts in here into an integer. Now, I expect that the person is not a very bad person that wants to kill our system or fry our our system, so the person would use ints with their good minds, all right, and put integers here. So if I run this now, then you can put any integer, all right, that you like, but you can still put a string and you can see, look at this. So it's telling you that it's invalid because we're expecting an int. That's that error I was telling you will happen when somebody tries to run this, all right? But if I run this and put an integer, no problem. So, but as we progress, I'll show you how to handle exceptions like this so that your code doesn't have to crash. Because anytime you're running a program like this and you see those errors, that error is actually a crash. It means that the program has crashed. So that is that kind of error that you see on your app when you try to do something and this program has crashed or this thing is beyond bounds or something. So that's how do you handle those errors so that it doesn't interrupt whatever the person is doing on the application. Yeah, so that's it. So now we got our shoe size. So the next thing we're now going to do is we're now going to say, okay, let us, where is that? Our flowcharts. So we got our shoe size. The next thing says multiply shoe size by 5. Remember, when we multiply shoe size by 5, we have to call it a name. So that name, let's call it results, all right? So let's go back here and then let's say results, all right, will be equal to shoe size multiplied by 5. So what's the next step? The next step is add 50, all right? So add 50, so let's add 50. And that becomes our new results, all right? Equals to add 50 to the old results. Sorry, plus 50. Then we go to the next one, which is to multiply by 20. So we will now come here again and state that we have a new result, and it is the result of the old results multiplied by 20. Now, at this point, we will have to check, have you had your birthday? So this is at the point where we now need a new variable to ask the question, have you had your birthday? Yes or no, all right? But in Python, we really do not use yes or no. So most times, if you want to evaluate Boolean conditions, we use true or false, all right? Some people decide to put yes or no in string, just a choice. But so here, we will need to create an if statement. But that if statement will have to evaluate, have you had your birthday? So it means we will create another variable called birthday. Let me just say had birthday, because that's one of the ways that Python uses the language. So for example, if you look at string methods, and you see Python say is birthday is lower, and they return true, is, or has this, has that. So that's one of the ways that Python lets you know, okay, what we want to do is we want to evaluate a condition. So let me use has birthday, all right? So what that would mean is I would need another input, but this time I would use true or false. I'm trying to see what the best way is to implement this now. Okay, let me see. Okay. Inputs. Have you had, let's see, have you had your birthday? So what I'm doing is I'm asking for an input, and I am asking if you have had your birthday, and I'm asking Python to convert whatever input there into a Boolean. So let me see if this works. Okay, enter shoe size. Let me see 10. Have you had your birthday? So let me use true. Okay, let's see how it works. Okay, cool. It works, it doesn't crash. Okay, so let's see. So at this point, we'll now implement the if. So if has birthday is, okay, I told you doing this is bad, all right? So let me see, if has birthday, but okay, this is one point where you might actually do this, because we're receiving the inputs, all right, from here. Okay, another way we can even implement this so that we don't cause confusion is to implement it like this. So I would now say enter, sorry, I'm not supposed to do that. Say type true or false. So that way, everybody knows that they are supposed to type in true or false inside. So if this is, let me now use this text, true, all right? Then what should Python do? Python should add 1020 to results, okay? So So if this is true, then results would be equal to results plus 1020, else, which should come here, else we'll get an error. So else results would be results plus, is it plus or minus now? Okay, add, or 1019. All right, so let's have 1019 here. And then after this is done, what should happen? Subtract year of birth. So that means we need to create another variable called year of birth that the person will have to enter. So let's create this variable, year of birth. All right, and this year of birth, okay, I forgot the bool before the input. Yes, I purposely did that so that it does not cause confusion for our code. But I'm going to show you what happens to it when I'm done with it like this. So year of birth will be equal to, this should be an integer, and it will take an input that says enter your year of birth here. So the final thing would now be subtract year of birth from results. So the final results, which is what we're going to be working on right now, will now be equal to year of birth minus the former results. Okay, so let's run it. Enter your shoe size. So let's enter shoe size 10. Then enter. Have you had your birthday? Type true or false. So let me type true. Enter your birth here yet. So let's pick somebody that was born in 1980. All right. Okay, so great. It works. Now let's print results. You can either use print results or just write results there. So shoe size 10, true, 1980, 1040 minus 1040. Okay, this minus is not, oh, so this is why I have it.
Yeah.
It should be results.
I wanted to say that.
It's the result minus year of
Results
birth.
minus year of birth.
Okay, cool. Yeah. So why did you not say it when you wanted to say it, Tima? All right, so
I wasn't sure, I wasn't seeing the those chart you did.
oh, okay. I should have
Yeah.
increased it. Now you should have told me that you weren't seeing it. So I should have increased the size. So let's pick somebody who was born 1980. Okay, so it means that his shoe size is 10, which is obviously this, and then he's 40 years old. All right. So is that
But
correct?
somebody born in 1980 is not 40
It's not
years.
40, right?
Yes.
Okay. So basically, okay, so it means that, let me see, it should work. Okay, let me use this person. This person was, let me see. Okay, this person is 47, okay, and was born 1973. All right, no, this is not 40. 1973 is not, is it 47 this year? 1973 to
1973 should be,
let me just get that quickly.
no,
So
49.
It's 49, right? So
Yes.
somebody that was born in 1973 minus 2022, who has not had their birthday, it's 49. Okay. Okay.
Maybe if the person should have added
No,
to the
no.
final result.
I'm just trying to implement this. But another thing that is possible here is that this is a web page, so it's possible that this document was prepared 2 years ago or something, and they were looking at.
And yes, we can add 2 to our final results again.
Okay.
Because since we've done 2 and it's both are variables of 2, so let's just add 2 to the final results
Seriously.
again.
Okay.
Or better still, where the person used 1020, we can use
1022.
1022 and 1021.
Okay, because
And let's see if it's going to work.
Okay, maybe what we can do is let's see if this person's year of birth. Let's see. Okay, this is So this person is 40. Do you remember what they were doing was as at 2 years ago, right?
Yes.
So it means the logic is correct. Yeah, it's correct. Because if you remove 2 from the present age of the person, you can see it lands at 40. But the person that has had their birthday is 42 already. So, it's one of those, this is one of those, what do you call it now, that they send. They say, you see this a lot on WhatsApp and on maybe Telegram. Yeah. They say, do this, do this. This will only happen this year, it won't happen another year. So
that's true.
Personally, I don't know how they come about all of that. I just think one cycle just comes up with it. Because I know these are all mathematical stuff, and so yeah, somebody just comes up with it and somehow it just works.
It will work.
Yeah, yes. So that's how to implement that. So you see how we build step by step, until we land at the destination that we want to get to. So that's basically how we just you run your stuff. So if you have any questions, I will be glad to take it now. And we could dispatch with those questions. Have any questions? Okay.
No, I don't have any question, but I'm just curious.
Yeah.
If I want to run this type of program,
yes,
no wonder I get confused every time.
Okay.
Where you use result, I'll have been using new result or results one.
Yeah.
I know I'm still a baby programmer.
Well, yeah, go ahead.
I am sure that's what was running on my brain when you showed that. I was like, to be results one.
No. When
Thank
you do
God
that,
I joined this class. I think I've learned something today again.
When you do that, you end up with a lot of garbage, variables that you might not even call in the course of running your application. They're just garbage variables, because you can see that here we had to say if the person has their birthday is true. All right.
Yeah, the if statement.
Yes. On some occasions, we might have needed to give this thing a name, this step. All right.
Okay.
Might have needed to create a step with a name. So if you have been naming result 1, result 2, by the time we get to this step will probably be result 7. Now, by the time you now check that if this person's birthday is true or whatever, and the condition is not true, that means you have added one garbage variable inside your program.
So the question is, for every result, Python will choose the latest results.
Yes. Yeah, that's what happens.
Okay, what if you want to refer to the previous results?
That's another good question. But the next question will be, why would you want to refer to the previous results?
Okay, take for example, name your variable x equals to 5,
right?
Y equals to 10.
Okay.
Okay, x plus y equals to 15, Abi.
Yeah.
That's one result, Abi.
All right.
Okay, result equals to x plus y. Okay. I don't even have confused.
No, truly, there are very rare scenarios where you might need to use multiple names for your results. Very rare.
Okay.
Now, well, one of those scenarios might be when you need to call on that result later, as an intermediate step in some other calculation you're doing. But in those scenarios, it's usually best that you create a function instead of just having loose values of variables just, hanging up and down. So I wish I could show an example right now, but we're out of time because the next class should be starting in 15 minutes. But yeah, and I have to set up for the next class. But I think that usually in such situations, it's just best to create a function. For example, we can package all of this inside a Python function. All right, by just putting def here, and just call this def shoe size game. And then we tell Python at the end to return results. When we run this thing, we can even now come here and just call the stuff. So just say, here we will supply the variables here. All right. So the variables that should go into this shoe size finder would be shoe size, might just also be year of birth, and has birthday. All right, so when we create that, then all that needs to happen is that when we want to call this, all right, instead of using int input, and all of this, what we can do is we'll just call this shoe size game function, all right, and supply the shoe size. So it will be something like this: shoe size equal to whatever parameter you want to have, all right? And then the other one has birthday equal to this, and then year of birth equals to this. And once you just run it, it automatically walks through all the processes there, and it just brings out your stuff for you, the answer.
I have another question. I'm so sorry.
No, you don't have to be sorry. You don't have to be sorry.
Okay, my question is that in the third line of code, that result equals to shoe size times 5.
Yes.
Can't we write something like this, like result equals to shoe size times 5 into bracket plus 50 or bracket times 20, instead of having to write all this?
Yes, it's very, 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 very beautiful. You get it will work. We can do that right now, and you see it will work perfectly. But one of the rules of programming is readability. So would you want to end up with a code that tomorrow you will have to even try to explain to yourself? What was I trying to do here? Do you understand? I've had those kind of code. Sometimes code that I've written 1 year ago, I'll just pick it up and I'm like, wait, why did I write this? I'll look through all because sometimes you think you have even written documentation, you have made your comments on the code very well. You not even try to read the comments. Wait, what was I trying to comment here? It could be very, very, very stressful when you do that. So So most times I would prefer readability than having compact code. If you notice, if you look at most of the codes that I write, for example, I see a lot of people write list comprehensions. We're going to look at all of that, maybe list comprehensions, dictionary comprehensions, all of that. But because I know myself, I would rather just write my for or my if like this, instead of writing it like this. You can see, I can have my if statement like this.
Okay.
Everything in one. So shoe size for shoe size and shoe size for if A is this, everything can be in one line. But I know that tomorrow, if I'm reading this thing, I'll be like, what was I trying to do here? So that's why I would rather, instead of having it, in a list comprehension like this, I would rather have it like this, so that I will know, okay, this was what I was trying to do. I was trying to equate this to this. Okay, so that if this is not this, oh, okay. So that's just it basically.
Now, my final question.
Please go ahead.
Okay, sir. So after all this, this question is not. I know it's not for this class, so I know it's higher than me, but let me just ask, because that has been how I put it. I've been curious about that. Okay, fine. You said that this is a program for an application. That's shoe size application.
Yes.
So make it an app. How do we continue from here?
In fact, what you have asked is a very beautiful question. Now, let me show you. Let me get back to my Visual Studio and see if I can pick out one of the projects that we did. It was a very simple application we tried to build. Okay, let me see, integrated inventory app. Let me see. Okay, cool. So I think we need this here. Now you can see all the code that we had here like this now. There are different GUI applications, right? What's a GUI? GUI is graphical user interface. Now there is Tkinter, there is PyQt, there is Kiwi, there are like 20 or so different GUI packages. So all we need to do is just to pack those functions that we wrote, all right?
Okay.
And just package it inside a GUI like this now. Create the main window, create the menu bar, create file menu, create all the menus like that.
Okay.
And we'll be fine. So if I run this one now, let me run this. Let me run this. Okay, so can you see the application here? So can you see?
I'm seeing it.
Yeah. So I can decide to say, okay, I want to package this thing that I wrote inside this Tkinter app to just say, okay, create guessing game, and then once somebody presses this print, then it should print out I think I have one temperature converter. There's one I had. Let me see. There was one we did in class. I think it's this one. Temperature. No, it's not this one. It's not. This one is inventory manager. I think the app is temperature manager. And this is Streamlit. Let me see. Where did I keep that application? I think that's for temperature calculator. Okay. So if I see that, I will let you know. But I thought I had that thing here. It's like a temperature calculator that calculates temperature when you run it. So it had everything just populated on the inside. And then this is not it. But okay. I thought I had it though. I thought I had. Oh yeah, okay, good. So this is one. This is a very good one. Let me just run this one.
Okay.
This one is like a currency converter. So what you do is you enter the amount here. So you can see all I've done is just to create the functions and just wrap it inside this tkinter GUI that creates this thing. So I can expand it, right? But I purposely did not expand it because the app is just a very small app. So I'm just going to say enter USD amount here, and I put the USD amount that I want, say maybe 100 USD, and I click that I understand the terms and conditions of using this app, and I click on calculate, and it tells me my 100 USD is equivalent to this 200 pounds. So it's the same thing. You can just put in your shoe size here, and when you press calculate, it will now go and run all these codes that you have here at the background, and just bring it out for the person and say your year of birth is this and your age is this, or your shoe size, whatever. Just brings it out.
I still have a lot to learn.
Yeah, we all still have a lot to learn, all of us. Not only you.
Baby.
Not only you. We all still have a lot to learn. So
Okay, let me just take it step by step.
obviously,
Now
that's the plan.
so
Now
I'm
you
no longer
know.
curious.
Yeah.
I just want to see though, but now that I've seen, I'm no longer curious.
Yes.
So I'll take it step by
Funny
step.
thing is that you can even build this into, you can even make it more beautiful. You can build it into an Android app. I think I had one. Let me see. This Kiwi. Let me see. There's
So
an
you said
Android
you have
app.
a class in the next 15 minutes. Don't
Yes, it's
forget
true.
about that.
It's true. It's no more 15 minutes. It's now like 9 minutes. So I have to shut down. I have to shut this down. All right. So I have one Kiwi app somewhere.
Probably
I
in
would
the
have
next
shown
class, I'm
you.
going to ask.
Yeah.
I'm going to ask in the next class.
Okay. Okay. No
I won't
worries at
forget.
all. Okay. Okay. No problem. All right. So
All right, sir.
I will make this available in the chat as usual, so that everybody can.
Okay.
Yeah. That's so we'll be fine. Okay. So this is where we call it a day. And
Right, sir.
say everybody goodbye. Okay.
Bye, sir.
Bye. Bye, Tima. Bye, Okay. Bye, Indita. And we'll see you in the next session.
Thank you.
All right. All right.
Bye.
Then. Okay. Bye.